How do protons become neutrons in the core of a star? In the core of a star, protons can become neutrons through a process known as beta plus decay, or positron emission. This occurs in the extreme conditions of temperature and pressure that exist within stars, particularly during later stages of stellar evolution. Here's a detailed explanation of how this transformation happens. The process of proton to neutron conversion. High temperature and pressure. In the core of a star, the temperature and pressure are extremely high, millions of degrees, which leads to intense nuclear reactions. These conditions can cause subatomic particles like protons to interact with each other in ways that would not occur during normal conditions. Positron emission. Beta plus decay. During certain stages in the star's life, especially massive stars nearing the end of their life, when their core's temperature reaches a point where the nuclei are highly excited, a proton in a nucleus can interact with an electron, resulting in the conversion of the proton into a neutron. This process is known as beta plus decay and involves the emission of a positron, E plus, and a neutrino, V. The reaction can be summarized as P arrow N plus E to the plus V epsilon. Proton P is converted into a neutron. Positron E, the antimatter counterpart for the electron, is emitted. Electron neutrino V epsilon is emitted as well. What happens to the positron? The emitted positron, which is the antimatter counterpart of the electron, quickly annihilates with an electron, producing gamma ray photons. This helps to maintain the balance of energy in the star. Why does this happen? In stars, and especially in those that are old and massive, the core can be made of heavy elements like carbon, oxygen, or neon. As the star evolves, the core becomes increasingly hotter and denser. At these temperature conditions, the process of proton to neutron conversion via positron emission can help stabilize the core and facilitate further fusion reactions, like the fusion of heavier elements. Proton to neutron transformation in the context of stellar evolution. In main sequence stars like our Sun, proton-proton fusions occur, where hydrogen nuclei protons fuse to form helium, releasing energy in the process. A massive star nearing the end of the life cycle, when the core temperature reaches higher values, more complex fusion just repeats it. In summary, protons become neutrons in the core of the stars through the process of beta plus decay or positron emission.